SolarOpen 2 has 250 billion parameters, yet Upstage says only 15 billion activate for each token. That sounds like a monster model running with small model compute. The catch is hiding in one word: active. Released by Korean AI company Upstage, SolarOpen 2 is an open-weight, agent-focused model supporting English, Korean, and Japanese. Its pitch combines huge capacity, selective computation, long context, and self-hosted control. The 250B number describes the complete parameter pool. The 15B number describes roughly how much participates in computing one token. Those are different measurements, and confusing them creates wildly unrealistic hardware expectations. This works through mixture of experts. Instead of sending every token through one enormous feed-forward network, the model keeps many specialist networks and routes each token through a small selected group. Upstage lists 320 routed experts, plus one shared expert. For each token, the router selects 8 routed experts, while the shared expert participates consistently. Different tokens can wake different specialists. Imagine the word function entering the network. A learned router scores the experts, chooses its top candidates, combines their outputs, and passes the result onward. The next token may take another route. Although each token touches only part of the model, the overall pool can store broader patterns and specialized behavior. The hoped-for trade is large model capacity without paying dense model computation on every step. Selective activation reduces arithmetic, not the model's existence. The system generally needs access to all 250 billion weights because the router could select different experts as the sequence changes. At 2 bytes per BF16 parameter, raw weights alone are around 500 gigabytes before runtime overhead and context memory. That is why 15B active does not mean a normal 15B download. The model card lists 4 NVIDIA H200 GPUs as the minimum BF16 setup and recommends 8. Its quick start examples assume 8 GPUs with at least 141 gigabytes of memory each. Upstage says quantized deployment can run on 2 H200s, and official quantized variants are linked from the model card. Quantization compresses weight precision, trading memory savings against possible quality and speed differences. So yes, SolarOpen 2 can be local in the on-premises sense. Your machines, your network, your data. But no, this is not casual single GPU desktop territory. Upstage is not selling this primarily as a chatbot. The company says training emphasized search, tool calling through MCP, coding, document work, and office tasks that require multiple actions and verification. An agent may plan, call a tool, inspect the result, revise its approach, and repeat. Even efficient tokens become expensive when one user request triggers dozens of model turns. The release post says tool use examples were executed in real environments, then checked by reading back the changed state. That targets a crucial gap between plausible instructions and completed work. For coding data, Upstage describes agents working in terminals, writing tests, running them, and fixing failures. That loop matters because real coding agents must recover, not merely produce convincing first drafts. Aju Press reports that Upstage built a simulation environment called Officeverse for document writing, spreadsheet analysis, presentations, and coding. The aim was evaluating whether actions were actually correct. SolarOpen 2 also claims support for a 1 million token context window. That could hold huge code bases or document collections, but maximum context is not the same as perfect recall. Its 48-layer stack repeats one softmax-attention layer, followed by 3 linear attention layers. That means 12 layers use conventional attention, and 36 use the more memory-conscious linear design. Only the softmax layers retain a conventional key-value cache. Upstage says this holds long context memory to roughly 1/4 of an all-softmax model with the same shape. The softmax layers use no positional encoding, while linear layers carry order in recurrent state. Upstage presents this NOPE design as a way to avoid rotary position extrapolation limits at extreme lengths. Hybrid attention lowers memory growth. It does not make million token prompts free. Prefill time, cache allocation, batching, and useful retrieval still determine whether that headline context works in production. Upstage says its tokenizer uses fewer tokens for Korean than the global models it tested, between 50 and 80% as many, generally, with a reported 24% lead on office text. Fewer tokens can mean lower inference cost, faster processing, and more real content inside a fixed context window. For Korean organizations, that efficiency may matter more than another English benchmark point. Training did not begin entirely from scratch. Upstage transferred a compatible 2.3% of weights from the previous Solar model, while initializing the rest for the new architecture. In a controlled proxy experiment, Upstage says transferred initialization reached target loss after about 12 billion tokens versus 22 billion from random initialization. Useful result, but still company reported. The published numbers are eye-catching: 86.2 on MMLU Pro, 92.4 on Live Code Bench, 80 on IF Bench, and 58.2 on MCP Atlas. Upstage compares these favorably with several leading models. Solar Open 2 reportedly scores 70.4 on SWE Bench Verified and 16.6 on Apex agents. Those suggest serious capability, while also showing that difficult end-to-end agent tasks remain far from solved. These results come from Upstage's release materials, and some Korean benchmarks are explicitly marked in-house. Until independent evaluators reproduce them, treat the leaderboard as evidence to investigate, not a verdict. A model can ace coding questions, yet fail your repository, tools, language mix, or permission boundaries. The decisive benchmark is a representative workload with logged errors, latency, and cost. The weights are downloadable, and commercial use is permitted under the Upstage Solar license. That is open weight access, but builders should not casually translate it into unrestricted open source. The model card says derivative AI models must use a Solar name prefix, display built with Solar publicly, and include the license notice. Product teams should review the full text. Upstage frames this as Korea's sovereign foundation model, infrastructure that organizations can deploy, inspect, and adapt without routing sensitive data through a foreign-hosted API. That framing is strategically significant. The release also broadens the model landscape beyond the familiar American and Chinese axis. Regional language efficiency, workplace conventions, and deployment control can be product advantages, not side features. Solar Open 2 is most relevant to enterprises, labs, and service providers with multi-GPU infrastructure, sensitive documents, Korean workloads, or enough repeated agent traffic to justify self-hosting. Start with your hardest real tasks. Measure tool call validity, completion rate, long context retrieval, tokens consumed, latency, and GPU utilization. Then, compare the quantized model against a strong, smaller baseline. The exciting part is not pretending 250B became 15B, it is coordinating sparse experts, hybrid attention, multilingual tokenization, and agent training to make a giant model less expensive to operate. Solar Open 2 is a fascinating open-weight release and a terrible excuse to ignore memory math. 15 billion parameters work per token. 250 billion still need a home. Efficient giant? Yes. Tiny local model? No.